All right, so we're going to look at the review for test 2. Make sure that you've actually worked out all the problems that you can on this review. If you haven't, you need to stop the video, go spend some time on the review, and then come back to this video. Because this video is just like kind of if we were in class and y'all were asking me questions. I'm going to go ahead and go over all the questions on the review and then talk about how I might have variations of those questions on the test. So it's really not going to do you as much good as if you just copy down what I say. Okay, you really need to try them on your own. So if you've already worked the review, let's go ahead and start with number 1. So the first thing is, notice I asked you to identify the independent and dependent variables and then state how you would explain the difference. So maybe off to the side, you need to make sure that you know how to explain the difference so that you could explain it to someone else. The independent variable values can change freely. That's what it means to be independent. While as the dependent variable changes as the independent variable changes. So dependent variable values change as the independent variable value changes. So I kind of did that just off to the side so I didn't have to do it for each of these individual examples. Okay. So in number 1, you have to decide which one is the variable that's changing freely and then which one is the one that's changing as the other one changes. So when you look at part A, a painter must measure a room before deciding how much paint to buy. So you got to ask yourself, does he buy the paint and then decide what the measurement of the room is? That doesn't really make any logical sense, right? Or does he measure the room and then decide how much paint to buy? That makes more logical sense, right? So the independent variable, in other words, the variable that you don't really have any control over, it just kind of is what it is going to be the measurement of the room. And then depending on that, we'll decide how much paint he has to buy, right? So the dependent is how much paint. Okay. Part B, the height of a candle decreases d centimeters for every hour it burns. So again, you need to think about maybe the variable you don't have any control over. So I would say the variable you don't have much control over is the hours you burn. Well, I mean, you kind of have control over it, right? You could blow it out. But this kind of just is what it is, okay? And then the dependent variable, having to squeeze it in here, I need to leave more room, is going to be the centimeters of candle burned. And then lastly on this one, a veterinarian must weigh an animal before determining the amount of medication needed. So the thing the veterinarian wouldn't really control is the weight of the animal. But once we know the weight of that animal, right, then the amount of meds would be dependent on that. Okay, so when we talk about functions, we want to kind of get away a little bit from calling them always x, y coordinates because it's not always the letters x and y. But on the horizontal axis, your independent variable should always be your x/horizontal axis, and then your dependent variable should always be your y/vertical axis. Okay. Okay. So let's look at number 2. Okay. So Ben went walking. He started at 8 a.m. And he walked 7 kilometers. Can't talk. In the first 2 hours, and then blah blah blah. So it looks like we can go ahead and kind of set up our graph. I do want y'all to label these graphs. I want them to have a title. I want them to, the axis to be labeled. So it looks like we're going to have time versus distance from home. Looks like the distance from home is going to be in kilometers. Okay, so I'm going to start this time at 8 a.m. And then, let's see, we're just going to start counting up, and then we'll see if we need to count further. Okay. So you might want to kind of write out, maybe underline what the important details are. And this is titled Ben's Walk. All right, so he started walking at 8 a.m. and he walked 7 kilometers. It looks like he walked 5 kilometers further, and it looks like that's all he walked, so 12 kilometers. So I'm just going to start counting by twos. So you are going to need to pick an appropriate scale for your graph. And some of you are not necessarily getting the scatter plot questions right later on because you're not picking an appropriate scale for your graph, and you're being a little too like loosey-goosey with your graph. You need to make sure that it looks pretty good. All right, so it looks like at 8 a.m. he starts, right? So he's at home at 8 a.m., 0 distance from 0 kilometers distance. He walks 7 kilometers in the first 2 hours, which means, you know, 7's maybe about right here. So at 10 o'clock, he's 7 kilometers away. Okay. And then it says that he rests for 30 minutes. Well, that means he's not going anywhere, right? So at about 10:30, so maybe you need to go halfway here, he's going to rest. Okay, so far he's walking, he's resting. And then it says he walked 5 kilometers further in the next hour. So from 10:30 to 11:30, he walks 5 kilometers further, so all the way up to our 12. He spent an hour having lunch, so we do need to go further, and then he starts walking back for 3 hours. So we're actually going to need a few more hours here. So this is 1, 2, 3, 4. This is 1 p.m., 4 p.m. Okay, so he's going to have lunch for an hour, which means from 11:30 to 12:30 he's going to rest, right? He's not going to go anywhere. Try to make that flat. And then for the next 3 hours he walked home, right? So it's 12:30, so that's going to put him at 12:30, and then he's going to be home, right? Or sorry, not 12:30 to 3:30. He's going to start walking home at 12:30. Okay, so this is the kind of detail I'm going to want. Remember, this homework assignment was graphs to stories and then stories to graphs. So you need to make sure this one is a story to a graph, right? So notice I want more detail than maybe some of you gave me on the homework examples. Some of you just threw up a sketch and you didn't label or anything. The one on the test, I'm going to want some more detail, probably closer to this. Okay, so kind of keep that in mind. Okay. All right, number 3. Most of you did really, really well on this homework assignment, this part of it where you had to look at a graph and describe a story. I like some of the creativity that some of you used, but you just need to account for every change. So, for instance, I'm not going to write this one out. We're just going to kind of verbally talk about it. So if you were taking a walk in the neighborhood, right, for a while you walked, right, and then you rested, okay, and notice you walked at kind of an uneven pace here, okay, then you rested for a bit. Then you walked at a very even pace or a very, level speed, and then you rested again, maybe had a lunch or something like that, and then you began to walk back kind of at the same pace, okay? So here you have a steady pace, and here you have a not so steady pace. So if you were going to describe this, you would need to describe everything that's happening, the changes, also how this curve is different from this flat edge and all that good stuff, okay? As far as the second graph, it looks like the temperature is already, some level. It doesn't really tell us what. And then it stays steady for a bit, right? And then it rises pretty sharply before falling and then staying steady again. Notice it's just a little bit lower than it was at the beginning, so you would need to mention all of these things in your paragraph, okay? So make sure y'all go back and look at that homework example. I feel like that'll give you kind of some insight on that question. Okay, so I'm not going to write that one out. All right, so let's move on to number 4. Okay, so there was kind of a little issue with this. I feel like some of you maybe didn't necessarily do the best line of fit when we had this scatter plot. This was, we did maybe more than one assignment, but the one that I'm thinking of is the production cost one. And some of you just didn't have good prediction equations, so you need to make sure that you pick kind of a decent one. So let's go ahead and do our scatter plot first. So This is going to be our hours studied. And then this is going to be the grade. And if you think about it, that should make sense, right? How much you study for an exam usually has something to do with the grade you make, right? So the grade is dependent on how much you studied. So notice this little, I know it's a little hard to see, but notice this little kind of lightning bolt thing here. This means we're going to jump from 0 to something. So what I did here is I went from 0, and then I'm just going to start counting at 60. And then every other one, I'm going to go up by 10. So that little lightning bolt just says, hey, I'm not going to be scaled from 0 to 60 in this case, and that's okay. Notice we go from 0 to 5 hours. So this is going to be 0, right? This would be maybe 1, 2, 3, 4, 5, 6. I'm going to go ahead and go to 6, even though I think we only go to 5 on that one. Okay, so let's go ahead and get our scatter plot down. So 3 hours of study make us a grade of about an 84. 2 hours of study gets us about a 77. 5 hours of study gets us about a 92. 1 hour of study gets us passing, right? 0 hours of study gets us a 60. 4 hours of study gets us a 90. And then notice we have maybe 2 students here, right, that studied 3 hours, and this person only gets a 75. Okay. So when I look at these, I want you to kind of see that most of these lie in a line. I wouldn't say that these 2 are the best choices, right? These kind of lie outside the line. So if I were going to figure this out, I would probably look at these 2 points right here. Okay, because I think I have a reasonable line of best fit that can go through here. Okay, so notice here I'm not really wanting you to use the calculator. I'm wanting you to actually find the slope. Okay, in part B, what is the equation for the line of best fit? So we're taking what 2 points? We're taking this one and the 4, right? Those 2. Okay, so we're going to find the slope, right, which is change in grade over change in study time. So we end up finding a slope of 30 over 4, which reduces to 15 over 2, or if we want to use 7.5, we can. Okay, so that's part of the answer, but then we need to find the equation of the line. Now we could use y minus y1, but notice in this problem we actually have the x-intercept. Okay, or sorry, the y-intercept, so we can actually just use mx plus b. So it would be y equals 7.5x plus 60. Okay, that is our decent prediction formula for what the grade would be. Okay, so it says predict a grade for a student who studied 6 hours. So for that, you would just plug it in. Now on the test, I'm going to need you to show me the work, right? Like I'm going to need you to show me maybe more work than you think is necessary so that we know that we have a reasonable assurance of some test security. So just kind of keep that in mind. So notice this is going to be about 105. Okay. So notice this is too high unless they're a bonus, right? So I'm going to say too high without bonus. In other words, in most real-life scenarios, you're not going to have everything kind of fall in line. You might have some equations or some numbers that don't seem to kind of fit. So the one that I'm thinking of, I just graded a lot of your homework assignments. I'll be uploading those really, really soon. Is there was one when it was talking about distance from the object to the ground, and a lot of you got like a negative value. And so I wanted you to mention that that wouldn't have been possible, right? So 105 is, you know, in a normal test out of the realm of possibility, right? So part D says, could this line go on forever? Why or why not? Okay, and the answer is no, right? We just kind of proved that. First of all, there are limited study hours. In other words, we can't just study forever. We know that from personal experience, right? And also we can probably assume that the highest grade is 100. In other words, even if there are bonus points, the teacher's not going to continue to let you make a 200 on the test, right? Like that's not a thing in most tests. Okay. So again, just make sure that you know how to recognize linear systems and know how to make sure the answer is reasonable for the setting that you have. Not just in linear systems, really in everything. Okay. Okay, so let's go ahead and look at this next one, look at maybe a scatter plot. So you've got some choices here on how you want to set up your graph. So it doesn't really make much of a difference to me, but it looks like we only go to 8. So I think I'm going to maybe count by 4s or something. So 1, 2, 3, 4. This will be 1, 2, 3, 4, 5, 6, all the way up to 8. So it looks like we're going to make this the bounce number. Oh, by the way, up here, let's go ahead and make a title, right? So we'll say hours studied. So make sure you do that on your test here. And so the title of this one could be height of a basketball. So depending on the bounce number, and think about how that would work, right? The basketball would bounce the highest at first, and then it's going to start going down, right? I only need to really go up to 200. So I'm just going to start kind of counting by, I think I'm going to count by 20s. It won't take me all the way up, but I kind of made this graph quite large. So it's a little off. Hang on a second. That would be 60. So on the test, you don't have to pick the same scale that I would, but you do need to pick a scale that is including all the numbers and that is kind of even all the way around. In other words, it needs to be consistent. So this is the height of the bounce in centimeters. All right, so let's see if we can figure out what pattern this is. So it looks like we start off at a height of 200. At 1, we go to 120. So just kind of plot all of these the closest that you can. Notice I counted by 10s with each little unit, right? So I'm having to go even between the unit for things like 16 and all that. All right, so I'm just going to kind of connect this here. Okay, so notice clearly this looks to me, the graph goes down. This is the shape of an exponential pattern. Okay, so you had a question like this on your homework. You know, but another way to show that it's exponential, by the way, is just to go up here and kind of figure out how far away each of these are. Okay, and I think you'll find that it counts relatively close to like an exponential pattern. So in other words, here you're subtracting 80, here you're subtracting 48, here you're subtracting 24, and so on and so forth. So it's not going to be perfect, okay, but I think it's pretty close to an exponential pattern. And so let's make sure that we remember how to punch this in the calculator. So remember, we go to Stat, go to Edit. So notice I have a previous list, so my x's are going to be 0 to 8. So notice I have an extra line, so I'll just delete that one. And then my Y values are 200, 120, 72, 44, 26, 16, 10, 6, 4. All right, where did I miss one? I forgot my 120. So you'll know if you end up like I just did, kind of one off. In other words, I had too many numbers. They weren't matching up. So that let me know I needed to go take a closer look. Okay, so sorry it's too glary. Let me move that out of the glare. It's really not a great way to get this visible. So you edit your list, okay, and then you go back to stat and you go to calculate. Now we think it's an exponential pattern, so there's no need to write down every one if you kind of already know what kind of pattern it is. And then we're just going to calculate it. And so it looks like, all right, I'm going to check my numbers again because I did this before and I didn't get quite that number. So let me make sure I didn't make any mistakes. 44, 26, 16. Oh, for some reason, yeah. So notice you just need to be really careful. I put the wrong number here. So I'm going to change my list and then go back. I think I just kind of combined those two for whatever reason. All right, one point that is off will throw your lineup curve of best fit off. So it looks like the closest thing that I can get is about 194.09. And then it will be 0.61 to the x power. Okay, and the best way to make sure that this is right is go back and plug in some numbers and make sure that it's close at least. So like let's try it for 3, for instance. Okay, so if you do 194.09 times 0.061 to the third power, notice we want to get 44. What on earth am I doing here? It's a Monday, that's all I can say. All right, so notice we get pretty close to 44, right? So I know that's hard to see, okay? But I'm just kind of testing it out. If we test out another one, like let's test out 1, for instance. If you plug in 1, notice you get 118, which is not exactly 120, but it's pretty darn close, okay? So I tried 2 values and they're pretty close, so that lets me know my exponential pattern is probably pretty good to go. All right, so let's look at another one. Okay, so it looks like we have years 1 through 6, right? So we'll title this population. Oops, sorry, let me move that down. Population of caribou. It looks like the x-axis is going to be time in years, and that the y-axis is going to be population. All right, so obviously this is going to be 0 years, and then I'm just going to maybe count by, I don't know, 4s, kind of like I did on the other one. So this will be 1 year, 2 year, 3 year, 4 year, 5, and 6. We only really need to go technically out to 6, okay, so far. The population looks like it goes anywhere from really low at 24 to about 225. So what I'm going to do is I'm going to count probably just by maybe 10s. I think I can do 10s. So I'm going to go like 20 here. 40, 60. So I'm making every unit 10, but I'm only counting kind of every other one. You don't want to make your graph so cluttered and ugly that you can't really read what's going on. So I'm going to go up to 240 just because 220 is not quite enough. Okay. So let's go ahead and graph this. So at 0 years, when they were concerned about the population, in other words, we're about here, so that would be 30, so maybe here would be about 24. 1 year, we're at 35. So this is 30, so 35 is right there in the middle. At 2, we're at a little bit above 50, pretty much right on the line. And then so on and so forth. So just see if you can go ahead and plot all of these. So it's right there. Okay, so I'm going to kind of draw this here. Okay, so in my estimation, when I ask you what type of function it is, I think there are two choices. It could be quadratic, or it could be exponential. Okay, so in this case, you might want to come up with two equations and kind of see which one seems to be the better fit. So again, let's go back to our stat plot. See if I can sort of get in view here. Really nowhere is great. Doing the best we can with my kitchen counter here. So 0, 1, 2, 3, 4, 5, 6. So I need to delete those two. And then the population numbers are 24, 35, 51, 74, 104, 151, 225. And delete the two we don't need. Okay, so because I'm not sure, and you know, when you're doing this on your own, maybe you'd even throw cubic in there. It's not cubic, I'm not going to throw that one in there, but you might think that it is, so you could throw that choice in there too. So when we go to calculate, let's do both the quadratic regression and the exponential one. So notice we get two choices. Y equals 5.76 x squared minus 2.86x plus 28.52. Okay, and we're going to compare that with the exponential model. Okay, so notice we don't have to go back and enter in all the points. We already did it. We just need to go back to calculate and do the exponential model. So you had an assignment on homework where you had to, you know, figure out all the models and then kind of pick the one that fit the data the best. So this one looks like 24.13 and then times 1.45 to the x power. Okay. So this one's kind of close, and again, you could go up here and kind of do some figuring, right? Like from here to here, we added 11. From here to here, we added 16, added 23, added 30, added 47, added 74. Okay, started off somewhat steady, but then notice it's growing by leaps and bounds here. Okay. So the best way for you to pick out the correct one would be for you to test some values. Okay, so I'm just going to pick a couple. I'm going to pick like 3 years and 5 years. So let's check it out. Okay, so let's try 3 years. So let's try the quadratic one first. So 5.6 times 3 squared minus 2.86 times 3 plus 28.52. Okay, notice the answer for 3 is supposed to be 74. Okay, so we get 71.78 here, so sort of reasonably close. Yeah, there's just no way. I'm not really showing the greatest view of that. I'm sorry about that, but that's all we can do here. Notice, though, that the exponential model is really close. So all I did was plug in 3 to my exponential model, and I got 73.56. So far, the exponential model looks pretty good, but you do need to try more than one, so let's try 5 years. So what I'm doing is plugging in 5 to my quadratic model, and I'm going to compare that by plugging in 5 to my exponential model also. So notice at 5 it's supposed to be 151. Okay, on the quadratic model I get 158. So let's see what I get on the exponential model. I get 154. So I think the exponential model is the better choice. So sometimes you just kind of have to trial and error it like that. Like if you have a shape that you're not quite sure about, then you have to kind of plug them in. So this one I think also was exponential. Make sure that if it's, you know, linear or exponential or quadratic, make sure, I didn't necessarily put a lot of this on the review, but I could include it on the test. So make sure you know how to do things like find x and y intercepts for different types of equations. Make sure you know how to use Pythagorean theorem, not Pythagorean theorem, sorry, quadratic formula if it's a quadratic formula problem. So we had a couple problems where you had to use quadratic formula, but the one that I can think of in my mind is the path of the rocket exercise, where you had to, you know, find out what the peak was, which required you to know the vertex formula, right? And then you also had to find out at what times was the object on the ground, I think, or at ground level or something like that. So make sure that you know how to find those if the equation happens to be quadratic. But this one I think is also exponential. Okay. So if the pattern continues, approximate the population in 9 years. Make sure that your answer makes sense. So because this is talking about animal quantities, you can't have, you know, a decimal. But if you plug that in, so if you plug in 9, you're going to get about 684 caribou. Okay, so remember the different models that I could ask you about on the test. We had linear, we had quadratic, we had cubic, we had exponential, and we had logarithmic. There are more, but those 5 are the only ones that I had homework assignments on, so you can pretty much guarantee that your test questions where you have to find curve of best fit will have something to do with those 5. All right, and then for the rest of the review, it's all kind of the more junior high / even elementary level problems. So I'm just going to kind of run through these kind of quickly. I think you remember these. Notice it says that she put in 3 of these, and we're just going to kind of work backwards, right? So 3 nixes. She put in 3 times as many carrots as nixes, which means these are 9. She put in 6 fewer miffles than carrots, so that would be a 3. She put in 10 more peppers than miffles, so that would be 13. And then, let me add that up. So, I'm just checking my answer here. 3 times as many carrots as nixes, 6 fewer miffles than carrots, 10 more peppers. Yeah, so if you add all of that up, you're going to get 28. Okay, so notice working backwards is the technique we kind of use here. So I even think this could technically be an elementary school level problem. I think our elementary school students could kind of work that out if they needed to, especially because you say what the last one is, right? And then they can just kind of work backwards from there. So working backwards is kind of a pre-algebra technique, so that's why we kind of talk about those kind of problems. All right, so let's look at a couple bug problems. You just need to make sure that you can show me all the work. So on the homework, remember I made you state what the independent variable is and then tell me which equation you used. So I didn't leave a space for that on the review, but on the test I will ask you to do that as well. So notice that we have 1 more ladybug than grasshopper and then 1 more grasshopper than cricket. So it really doesn't matter which one you decide is the independent variable in this case. The next one, it's a little more important. So let's just say that I decided to make grasshopper the independent variable. So that means grasshopper is G. Okay, so if you're going to make G the independent, then you already know the grasshopper, right? There's 1 more ladybug than grasshopper, so we can say G plus 1. And then there's 1 more grasshopper than cricket, which means this is actually G minus 1. And there's 12 insects in all. So when I ask you for the equation, this is kind of what I'm looking for. I'm looking for, okay, we have a G plus 1, we have a G, and we have a G minus 1, and all that together equals 12. So you can go ahead and simplify, and I would want you to. So here we would have 3G equals 12. Okay, but notice that's only because the 1's cancel out. So if you divide by 3, you get 4 here. Okay, 1 more than that would be 5. 1 less than that would be 3, and notice they all add up to 12, so we're good to go. Okay, but make sure you can show these steps. Okay, In part B, you need to be a little more careful with what you choose as your independent variable, because I really would prefer not to have fractions if I can help it. So if there are a quarter as many crickets as there are ladybugs, okay, then I'm actually going to make crickets my independent variable, because crickets is kind of the uglier one. So let's talk about what that means. That means crickets will be C. Okay, if there's a quarter as many crickets as there are ladybugs, then that means there's 4 times as many ladybugs. So notice I've avoided having to use a fraction, and I like that, right? And then 2 fewer grasshoppers than crickets, so this would be C minus 2. So as far as the equation goes, I want to see something like this. You've got 4C plus C minus 2 plus C, and that equals the 28 insects in all. So notice that gives us 6C minus 2 equals 28. Okay, so here's the equation I would want you to list if this were a homework assignment, and then we'll just add 2 and divide by 6. So we get 6C equals 30, and then divide both sides by 6. Okay, so even if you don't really need to show the work yourself, remember, you're supposed to be kind of modeling what you'll do as a future teacher, not just thinking of yourself as the student. Okay, so that's kind of the interesting thing about these education classes. You kind of are in both categories, right? You are a student, but you are preparing to be a future teacher. So in other words, I want to see your steps, okay? Particularly because you're taking your test at home. I want to see any step you can think to show me. I want to see it, okay? All right, so number 9, we've got blue, white, and red. There are more blue banners than white banners, and then there are fewer red than white. So first, what I like to do is I like to list them kind of in order. So notice, like, this is the biggest, okay? So it does go in order from biggest to smallest. So I'm going to say big to small here. So I listed them like that in the chart for a reason. Okay? In other words, we can't pick any options where we have the same amount of anything. Okay? So it says there are 12 banners in the box, some blue, some white, some red, so that means there's not 0 of anything. So I'm just going to kind of start at the top. The most I could have of blue would be 9, okay, because I have to have 12 items total. So I could have 9, 2, 1, and that would work. Okay. In other words, that's the only way that I can have not a 0 here. So maybe it's smart to start with the red when you kind of think of that, but whatever, however you want to do it is fine. Notice I can't do anything else with 9, right? I can't go 9, 1, 2 because then reds would be more than whites. Okay, so now I need to bump to 8. And I can't go 8, 2, 2 because, again, reds and whites can't be the same. But I can go 8, 3, 1. And that's the only 8 I can have, right? So now let's bump down to 7. Okay, so I can have 7, 4, 1. But don't forget I could also have 7, 3, 2. Okay, in other words, as long as my requirements are met, which just means it has to go cascading order here, right? Big, smaller, smallest. Okay, so then I can bump to 6. So I could have 5 and 1, but I could also have 6, 4, and 2. Notice I can't do 6, 3, and 3. Can't have the same. Okay. And then it looks like maybe I'm going to write it over here. I kind of ran out of room. So this will be blue, this will be white, and this will be red continued. So it looks like I could also have 5 here, right? 4 and 3. But notice I can't bump this any lower than that. I can't make this a 4 because then these would have to be bigger. So that's it. Okay, so on this, I would want you to make sure you can list all the possibilities. Okay, so we did some variations of this on the homework, so you need to make sure once I upload the graded versions today, you need to make sure that you go and look at that. Okay. All right, number 10. So we have 2 different kinds of aliens, right? Snoofs and snuffles. So we're going to let X be the snoofs. We're going to let Y be the snuffles. The point of making these aliens, by the way, is so that you have really no context for how much or what value these have, okay? Because, you know, they don't exist. So the point is to let the math drive you, not the situation, okay? All right, so notice that we know that x plus y is going to have to be, well, we don't know that, right? We weren't told how many items there were, right? But we were told how many antennas there are. So 3x plus 5y, and how I got that is every snoof has 3, right? Every snuffle has 5. In total, that has to be 28. So there's a couple of things that we can do here if we want to kind of limit what we've got. Notice this equation doesn't really help us at all. So what I did is I took the biggest one. So I'm going to go ahead and try to solve for that just to kind of make a point. So this is 5y equals 28 minus 3x. And then if we divide by 5, we get that result, right? Okay. So one way we could kind of think of it is that this is going to have to be a multiple of 5 to evenly divide. I don't know if that really helps you out or not, okay? But what it basically means is we're going to only have multiples of 5 here in the number of antennas, okay? Maybe that helps, maybe that doesn't. In other words, 5 times y has to be the same as what we have over here. So maybe that helps you kind of limit it down. But if this were 1, right, there would be 3 antennas here, okay, which would leave 25 here, so there must be 5 of these guys. In other words, this number here, what I was trying to say here, but maybe not so well, is this number here is going to have to be divisible by 5. Okay. Notice if you do 2, and we can try it, right, and we can kind of mark it out. If you do 2, you're going to get 6, and you're going to get 22 here, which is a no-go. Right, so you can kind of do that and kind of add them up. So when you take off this quantity from your 28, it needs to be a multiple of 5. Okay, so 3, 4, and 5 aren't going to work either. You could work them out and kind of cross them out. The next one that works is actually 6. Okay, notice 6 times 3 would be 18. That would leave 10 antennas, which would work here for 2. But then again, if you keep counting, it's not going to work, right? So the next one that would actually work for us doesn't exist. Okay, if you keep counting up, then it doesn't work. So it works out that these are the only 2. So I know I kind of skipped some work here, but you could literally go 1, 2, 3, 4, 5, 6 and realize that 2 through 5 are impossible because it doesn't leave an even amount of snuffles here. Okay, and then anything after 6 isn't going to work either. So just make sure that we understand that this needs to be a multiple of 5. And that's why we know that we're done here. Okay, that's what we kind of showed algebraically here, but if you don't really like that, you can just kind of notice that, hey, I'm going to need to divide this number by 5, and it's not going to work unless it's a multiple of 5. Okay. Okay. For number 11, cows and pastures. Okay, definitely make sure that you know how to do this. Remember what I said, I like to start on the smallest. Okay, so in other words, here and here, we know it's either 1, 2, or 2, 1. Like that's the only options. So you can kind of try them both and see which one works. But the one that's going to work is if this is 1 and this is 2. Notice that this would be 5 here, right? Because 2 plus 5 is 7, 1 plus 5 is 6. And then it looks like we have it. So this would be 6, 1 plus 1 plus 6 is 7, 2 plus 6 is 8. So we're good there. So I always start with the smallest amount. So let's talk about this guy. This is the smallest amount here. So it's either going to be 2 and 2, 3 and 1, or 1 and 3, right? So that's not a crazy amount of things to try. You can use your pencil and kind of erase as you go. But what works out is if this is 3 and this is 1, then this is 4 and this is 6. Okay, so I think you can figure it out if you just kind of work through it. On the test, make sure that you write dark enough. You definitely can use pencil, but you can't write really lightly because when you scan it, I need to be able to see your work in the scan. So kind of keep that in mind. Okay. All right, so on this one, I'm going to call these guys X's, the circles Y's, and we'll call the hexagons Z's. So I have the equation 2x plus y has to be the same as 2y plus z. So let's kind of talk about how we can reason this out, right? If it's 22 pounds total, then it means on the seesaw that each side is 11. Okay, so let's see if we can kind of work with that. So I'm going to start off with maybe the circle. Okay, that's where I'm going to start working. I'm going to treat that as my independent variable. So let's say that the circle was worth 1. If the circle's worth 1, right, then this side has to be 11. Then that means that these two have to be 10 together, which means each of them are 5. If this is 1, notice this would be 1 plus 1, right, which would be 2, and then take that away from 11, so that means this one must be 9. Okay. Notice that if we try 2, so let's go ahead and try it. If we try 2, we're going to get 2, right, which means these would both have to be 9 together, which means they're decimals, and we shouldn't be having any decimals. So notice, like, any even number is actually not going to work, so I'm going to kind of write that notice off to the side. Notice that the 0 can't be even, not 0. The circle can't be even. So I'm going to call this shape circle, so you don't do what I did and call it 0. It can't be even because it's going to make this odd, the double, and we can't divide an odd number by 2 and get a whole number answer. Okay, so let's just bump to the next odd number then. So if this is 3, then these are going to be 8 together, which means each of them are 4. 3 and 3 here would be 6, so that means this one must be 5. So I'm not going to bother with any of the even numbers. I'm just going to jump to 5. Okay. If this is 5, then it means there's 6 left over, which means each of the triangles must be 3. If this is 5 and 5, right, this must be 1. And notice I don't need to go any further than that because every time, notice the pattern, right? I'm going up by 2s here, I'm going down by 1s here, and I'm going down by 4s here. So I'm going to be taken into a realm that I can't have, right? 1 is the lowest amount of hexagons that I could have, so I'll kind of know that I'm done. And then the second part, notice each side would be 12 here. Okay. So notice this is a different scenario, right? So we can probably start with the circle again. So let's try 1. Notice if it's 1, right, then we have an odd issue here, right? If this is 1, that means these together have to be 11. Okay, so in this problem, notice that the shape circle actually can't be odd because we're going to end up with the same problem that we had before. So that one doesn't work. So let's just start with even numbers then. If this is 2, then the rest of the side would be 10, making this 5, right? 2 and 2 is 4. Take that away. That means this must be 8. So let's try the next even number then, since we already determined that the circle couldn't be odd. So if this is 4, we get 4, right? Meaning that these are also 4, right? And we can't have that. That's a no-no. Okay, can't have two things be the same. Okay, so we don't even need to finish that one out. So let's try 6. So 6, these would both be 3. But notice 6 and 6 is already 12, and so that would leave 0 here. So we're already out of options. Okay, so in this last problem, the only option is actually 5, 2, 8. Okay, so, you know, I definitely didn't do one of every single type of anything that we could have. I'd really just, the review is just kind of intended to be kind of a launching point for you. So later today I'm going to work, I've actually already graded all of your homework other than what you just turned in Sunday. And so I'm going to work to get that uploaded to you. That's going to take me a little bit of time, but at that point, maybe you can go ahead and start kind of evaluating what did I do wrong here, so that you can be prepared for the test Wednesday. So let's talk about the test Wednesday now that we're done with the review. We're going to do the review, or sorry, we're going to do the test during class, okay, unless you work something out with me otherwise. So I'm happy to work with you. You just need to let me know. So I don't know what you don't tell me. So if you have an issue with anything in the class, you really need to come talk to me or email me and not come talk to me. Can't do that, right? But you can email me. Again, I can't fix what I don't know is a problem. So make sure that, you know, the lines of communication stay open there. I am not going to have us Zoom in for the test. I just think technology-wise, not all of us have the ability to do that. Some of you are using your phones just to, you know, scan and all of that, and it's too much for that one device to do. If you're trying to hotspot a computer with your phone and then also use your phone for monitoring, for the video monitoring in Zoom, it's too much, okay? So I am going to upload a academic honesty statement with the test. And so basically I'm just going to assume that y'all are juniors and seniors, okay? So I'm assuming that I don't have to worry as much about academic dishonesty with y'all. And so what's going to happen is test time starts at 12:30, right? Class starts at 12:30. And so at about 12:25, I'm going to go ahead and upload the exam to your D2L. I am going to have multiple versions, so you likely won't have a friend that has the same version as you. But anyway, I'm going to upload that at about 12:25. Okay, and then what I'd like you to do, if you have the ability to print it, I'd like you to print it, and then you'll work the test, scan it back to me through Cam Scanner or another scanner. But if you don't have the ability to print, that's okay too. You'll just work it out on pieces of paper, but you need to make sure you're really, really detailed. In other words, I don't need you to write down the problem. For instance, on this pasture problem, I don't expect you to really draw this out exactly, other than, you know, maybe you could draw 4 boxes and tell me what goes in each one, okay? Here, I wouldn't expect for you to draw me the scale, but I would need you to show me what you got here. Okay, does that kind of make sense? So make sure that you really, if you're not going to be able to print, that's okay, but you need to make really sure that I know what problem you're on and that you're really neat and detailed if you're not going to be printing it, okay? And then so what I'm going to do is give you from 12:30 until 1:45 to complete the test, and then you have the last 15 minutes, so 15 extra minutes, so an hour and a half total, to get the scan uploaded on D2L. Okay, so that means you're going to have to be aware of your time. You're going to have to set a timer or something like that. So from 12:30 to 1:45 is when you need to test, and then if your alarm goes off, then you need to worry about going ahead and scanning your test and getting it back to me. Okay, I will be mindful of, you know, length of the test, but I'll be honest with you, you are not going to have time to flip through your notes on every question. You are not, okay? And if you do that, you're probably not going to complete the exam, okay? So kind of keep that in mind. I hope that you will do the test like you would in class, okay, and not look at your notes. That's what the integrity statement is going to say. But I'll just be honest, you are not going to have time. You know, what a lot of teachers don't really tell you about open notes, open book tests, is a lot of people waste time flipping through notes, looking up things they already know. Okay, so make sure that that doesn't apply to you. If you don't finish the exam, and it's because you've been looking up questions, I mean, that's kind of how that goes. Okay, so it's a time killer, and you don't have time for that. Okay, so you're going to have time to complete the exam in an hour and 15 minutes, and then time to upload that exam back to me. That's pretty much all you're going to have. Okay. All right, so I'll be sending y'all an email shortly. Just make sure you study. If my review video didn't go over something, or if you still have questions about it, or if you have questions about any of your homework that I'm going to upload to you later today, then definitely email me, and I'll be checking my email pretty regularly, and I'll get back to you as soon as I can.